Welcome to TFR Let's See. And today we have with us Todd Doane, Solutions Architect at SIOS Technology. And today we are going to talk about configuring SAP S/4HANA for high availability. Of course, we'll talk about it. And we're also going to see a demo of it in action.
Thank you. I really appreciate you having me back.
Let's talk about some basics. It may not always be clear how to build a high availability SAP infrastructure. Can you tell us what options are available to users?
There are really three options for high availability in the SAP infrastructure. You've got Red Hat Enterprise Linux High Availability Add-on and SUSE High Availability Extension and SIOS LifeKeeper Protection Suite. Both Red Hat and SUSE are integrations of Pacemaker, and SIOS is its own custom clustering software. The SIOS big advantage is simplicity and ease of use. Pacemaker is going to require you to build a lot of custom scripts to manage failover. With SIOS, we have wizards to configure the HA environment, which saves a great deal of time. SIOS Protection Suite is SAP certified, handles the data replication at the application level for your ASCS and ERS volumes. And SIOS handles database re-registration and can do manual or automatic switchback when a source comes back online. There are a ton of manual tasks when it comes to Pacemaker.
Now, it may look like that building high availability disaster recovery in SAP HANA environments can be complicated, can be complex. Is it really complex? And if it is, what leads to that complexity?
SAP HANA environments are incredibly complex, especially when you want to do HA and DR. They're so complex because you're dealing with multiple applications at different layers of the application stack. So you've got your presentation layer, which is easily protected, your Windows servers, and then you've got the application layer in the middle, which is where ASCS and ERS reside. And those need to be running on different servers, for SAP best practices. So if you have a failure, you need ERS of the ASCS node, you need to move the ERS to another node. And just anticipating all the places that there can be failover. You also have the integration with the database. You've got things like takeover with Handshake for maintenance of the database. Just an absolute ton going on in the SAP environment at any point in time, so that when you have a failure, being able to automate the failover and minimize your RTO and your RPO, it's just incredibly complex and difficult.
Can you share with us some tips, some strategies, how to simplify this, how to simplify your SAP HANA environment to ensure business continuity?
Yeah, so the best strategy is really to identify, plan, train, and test. You need to identify, all the places that you could possibly have a failover, which could be environmental, human error, hardware failure, software failure, power failure. There's just a number of places that you can have, a failure or a glitch. So being able to identify, as many possible potential places of failure as you can, and then plan to make sure that there are no single points of failure, and then train, all the people responsible for supporting and keeping that SAP HANA environment up and working and available, and then test. That's where many companies really struggle, is to be able to test the failover, test different types of failures within their system, and to make sure that when a hurricane does come and takes your data center out, that you're ready for it, and that your high availability and DR systems actually work the way you expect them to.
I also want to talk about the cultural aspect of high availability disaster recovery in SAP HANA environment. Talk a bit about how SIOS tools kind of build that culture and how right culture can help teams get most out of these tools.
Yeah, so the real culture caused by providing high availability for SAP and HANA stems from the fact that SAP has done such an excellent job of providing you, scripts, ways to monitor the database, the application, and functions that you can call to determine the health, fail the system over, and they've got all of these building blocks, but they're no real packaged way to implement all of those building blocks and functions that SAP has given you to easily create this high availability infrastructure unless you custom build scripts with Pacemaker, whether it's the SUSE or the Red Hat implementation. And then you've got to interpret and account for all of the SAP best practices. What SIOS has done is we've gone ahead and done all that work for you so that you can easily implement this high availability infrastructure when there's upgrades or changes to SAP. We've already handled any changes required in our software where an upgrade to SAP or to Red Hat may change the Pacemaker implementation and what you have to do to make sure that you maintain high availability and keep those SAP best practices.
And now it's time for a demo. Before we start a demo, tell us, what are you going to show us today? And then let's see it in action.
So today I'm going to show you two servers in AWS, and one is running ASCS, the other's running ERS. We're going to inject a kernel failure into the ASCS server. It's going to go down. The secondary server is automatically going to take over and start running the ASCS process. And then when the server that failed comes back up, ERS is going to automatically move from the currently active server to the one that failed as it comes back up in order to maintain SAP best practices.
Perfect. Now it's time to see it in action.
Okay, so here we have the two servers in AWS, SAP Demo ABAP 1 and SAP Demo ABAP 2. And I'm going to go over here. What we have is the LifeKeeper GUI. So here you can see I've got a 2-node cluster. There is a witness on these, but the witness is a storage witness using an S3 bucket, and that just prevents us from having any split brain scenario. So if these two servers lost connectivity, the witness would ensure that they don't both run the same process at the same time. So now what I'm going to do, and you can see the hierarchy here. So we have at the top of the hierarchy, we have ASCS, we have the IP address, which will move. This is a virtual IP address using the SIOS IP kit. Then we have the EC2 IP address, which that basically is an object that will change the route table so that when the address moves, you can find the server in another availability zone. And then we've got the ASCS volume, which is being replicated. So right now you can see the primary or the source is ABAP 1 for ASCS, and the target is ABAP 2. So this is a mirror. When we fail, this mirror will be the first thing to come up. In any point in any part of the hierarchy fails, the whole hierarchy will fail over to the secondary server. ERS is running on the secondary server. You can see here that process is active, and we have again the ERS volume is now the source is on ABAP 2, and that's being replicated over to the primaries or server 1. And you can see that they're synchronous mirrors, and it's fully replicated at this point in time. Okay, so my next step here is we're going to create a kernel panic in server 1. And you can see that that panic has caused everything to go down on server 1. So right now, hit refresh here. It takes a minute. We've got to miss the keep lives to recognize that it's gone down. And you can see that the data volume here has now become the source, the mirror, for the ASCS volume on server 2. And I'm running this GUI on server 2 so that we didn't lose the GUI if it was running on server 1. And so the volumes, it's showing out of sync to server 1 because it's down, but it'll reboot here shortly. And everything's up. The IP address is up. The only thing we're waiting for is the ASCS process to start. So that's started now. It's now active. And that quickly, we've failed server 1, and everything's up and running on server 2. Now we have to wait a minute for the server to reboot, and it should be fairly quickly. So right now it's coming back up. You can see here it's already back up in standby mode, but the replicated disk is out of sync, so it'll take a few minutes for that to sync up. And then there's a little bit of a wait period to make sure everything is healthy before the ERS process will start to move. So right now you can see that the ERS process has moved. It's started the move. We've already moved the source of the ERS volume over to ABAP 1, and the volume's up. The IP address is moved over for the ERS process, and now we're just starting the application right now. So as we go up the hierarchy, the process, everything starts at the bottom and goes up. So in just a minute or so, yep, there it goes. Now we're active on server 1. So by injecting that failure on server 1, we've effectively moved ASCS, failed it over to ABAP 2, and then ERS once ABAP 1 became available, automatically moved over. So we've reversed, which process is running on each server. Here you'll see that the disk is waiting to resync as we reverse the mirror direction. It'll pause for a few minutes. There, now it's restarted the synchronization process. And that's it. Really appreciate your time today. Thank you very much, Swapnil.
Todd, thank you so much for excellent insights and a great demo there. I look forward to talk to you again soon. Thank you.
Thank you.